warmly welcome you to our 83rd webinar by the Academy of Space Renaissance International. My name is Sabine Heinz, and I'm the person responsible for our webinar series. And on this 2nd of June, 2025, I'm really delighted you have come to join us. And we have today a very special guest. It's Howard Bloom, and he will talk about space. Oh, moment, I deleted the topic. Hello, Howard. Welcome to our webinar.
And I can tell you the topic.
Yes, I have it
book.
here now. The case of the sexual cosmos. Sorry,
Right,
I deleted
and
it
it's
here.
the implications of this book for space, and they're fairly startling.
Yes, thank you for helping me. And sorry, I deleted it here. I entered it and then I deleted it by any chance. And I also would like to introduce Adriano Ottino. He's also one of our vice presidents and former president and founder of SRI. Hello, Adriano.
Thank you, Sabine. Very welcome, Howard. I'm really curious to listen to your presentation. Very eager.
Yes, me too. Me too. Howard, before I give you the floor, I would like to introduce you to our audience. Space Renaissance International's guest, Howard Bloom, has been called the Einstein, Newton, Darwin, and Freud of the 21st century by Britain's Channel 4 TV. Bloom is the author of 8 books, one of which was the subject of a symposium thrown by the Office of the Secretary of Defense, including representatives from the State Department, the Energy Department, DARPA, IBM, and MIT. Bloom's work has been published in the Washington Post, the Wall Street Journal, Wired, Psychology Today, and the Scientific American. He is the founder of the Space Development Steering Committee, co-founder of the Asian Space Technology Summit, and a member of the Board of Governors of the National Space Society. Howard's Ellen Langer says that in the case of the sexual cosmos, Bloom makes a forceful and interesting argument that our understanding of nature is wrong. He argues that we are not savaging the earth as some would have it, but instead are growing the cosmos. A fascinating read. Concludes Joseph Chilton Pierce, author of Evolutions and the Crack in the Cosmic Egg. I have finished Howard Bloom's first 2 books, The Lucifer Principle and Global Brain, in that order, and seriously awed, near overwhelmed by the magnitude of what he has done. What am I? Oh, my cat. Oh, my cat is now taking away. Sorry. I never expected to see in any form from any sector such an accomplishment. I doubt there is a stronger intellect than Bloom's on the planet. And oh God, I give you the floor now before my little lovely cat is crashing my computer. It's a lady, and she has
That's an
always
adorable little kitten.
Yeah, she's very small.
Well, thank you for the introduction, Sabine. Thank you, Adriano, and thank you to the pussycat.
Yes.
Basically, the case of the sexual cosmos, everything that you know about nature is wrong, points to seven mistakes in our current view of space. People like Bernie Sanders in the United States say, yep.
Howard, when you want to share some slides or anything, please.
Oh no, I don't. It's just me. It's just words,
okay.
so we're fine. So Bernie Sanders likes to tell you that space is just a playpen for the ultra wealthy, for the billionaires. And if we had any sense at all, if we had any justice in our bones, we would not be sending missions to space. We would be using that vast amount of money to feed the poor and the starving on the face of the earth. And there's a problem with Bernie Sanders, but there's another assumption here. Underlying much of the environmental movement's objection to space is the idea that that if we simply wiped humanity off the face of the earth, got rid of every bit of human technology, this planet would be a green, luscious, and wonderful place. It would be a petting zoo for plants and animals. No more human interference. Wouldn't that be nice? Unfortunately, these assumptions are both false. They're tremendously false. I mean, first of all, nature has never been a petting zoo. Nature is red in tooth and claw, or green in tooth and claw. But more important, nature loves space programs. Nature herself is obsessed with space. It isn't just us human beings. When life began, 3.85 to 4 billion years ago, it was in the sea. It didn't stay that way for long. The first space program took place only a billion years later, when bacteria took to the land. That was almost 3 billion years ago when bacteria first took to the land. Now imagine that you are the ancestor of a bacteria that you've nicely divided in two, and you and your sister have both divided in two, and now there are 4 of you, and you, the young bacteria, are saying to you, the oldster, we're going to go exploring. We don't like being stuck here down in the sea. But where are you going to go? We ask them. And they would say, up. And you would say, but what do you mean, up? Don't you realize there are only 2 things up? One is 30% of the planet, which is this terrible, ghastly, hideous, absolutely barren and poisonous territory called, that's just stone. It's raw stone. Now, if you go up there, you're going to be minced to pieces by ultraviolet waves. Those ultraviolet waves are going to carve up your DNA. They're going to destroy you. There is no water up there except when it rains, and that is all too rare. There is nothing for you to eat up there. It is a barren and empty place. Surely the best that can happen to you is that you will die a quick and painless death. And despite us, environmentalist, conservative, green-loving oldsters, the youngsters have the audacity to start going to this terribly poisonous surface. And how did they do there? Well, for the next 2.75 billion years, the next billion, sorry, my math is all crazy in my head. So for the next, actually, it's 2 billion years, they live up there. And then multicellular plants begin to form in the seas. And the first multicellular plants take to the land. And that's 470 million years ago, after bacteria have already been on the land for 2.25 billion years. And the multicellulars, we would give the same speech to multicellulars that wanted to crawl on to the surface of the land. You're crazy. There's nothing up there. There's nothing to eat. It's a savage environment. It's a hostile environment. And yet plants took to the land, and today the amount of biomass on land is 70% of the biomass on Earth, despite the fact that the land is only 30% of the Earth's surface. So that is nature's first great space program, and it goes back a long time, nearly 3 billion years. But then plants became even more audacious about taking to the skies. Mosses, bryophytes, were among the very first plants on land. What did they do? They decided to explore the space above their heads. They rose to a height of 2 inches tall. That doesn't sound like much to you and me, but that's roughly the equivalent of 2 miles high in human terms compared to their body size, to the size of their individual cells. Then plants did something even more outrageous. They started, these bryophytes began to shoot their sperm 5 inches into the sky. Now, again, that sounds like nothing to us, but compared to the size of a cell of these bryophytes, that's 13.83 million or miles. Oh, bear with me on my zeros. That's 13.83 miles into the sky. That's 470 million years ago. Then animals came to the surface of the land, another insane space program. And then came an even loonier space program. About 400 million years ago, some of the earliest animals were insects. And those insects decided to take to the sky. Now, imagine you and I are their parents, and we would have said, what are you thinking about? Your entire idea of going to the sky is insane. Again, there is no food up there. There is no place to shelter up there. And if you fall from a very great height, you are dead. Nonetheless, some of these insane insects took to the skies, and they've been flying around ever since. That's nature's third great space program. Then came an outrage among the plants. It was an innovation. It was based on an innovation, a new building material, 2 of them, lignin and cellulose. And those initially were used by plants to build stems for plants that were very low to the ground, although even those plants were taking to enormous heights no living thing had ever seen before on a regular basis. This is before the insects took to the skies. But then, about 370 million years ago, a bunch of plants came up with an outrageous idea, an idea Bernie Sanders would never have approved of in a million years, that environmentalists would have said is the most outrageous lashing out against nature that you can possibly imagine. They decided to use lignin and cellulose to build structures that were giant tubes. And with those giant tubes, they went 70 to 100 feet into the sky. Now, look, from an engineering point of view, this is impossible. If the young plants had proposed this to some of us wiser, older plants, we'd have said, this is absolutely insane. Don't you realize you are dependent on water? And if you take to the skies in any way whatsoever, you're going to cut yourself off from water. Well, guess what the trees did? They managed to create a plumbing system that takes 11,000 gallons of water to the sky per day for your average 60 to 100 foot tall tree. 1,000 gallons of water per day they take to the skies. That is space transport on a big basis. That's a total of, in a day, that all the trees on Earth in a single day take as much water to the skies as the entirety of Lake Superior, one of the Great Lakes in North America. That's outrageous. And over the course of a year, they take ocean after ocean after ocean to the sky. That is a great big, well, how do I put this? A great big screw you to nature. And yet they did it. That was, if I'm counting correctly, the 4th great space program. And then 150 million years ago came another group of absolutely lunatic creatures who had no respect for nature whatsoever, and decided once again to take to the skies. And they were dinosaurs. And again, if we had been their parents, we would have said, look, the earth, do not dare depart from the surface of the earth. The earth has everything good that takes care of you. The earth feeds you. The earth gives you your nesting places. The earth is your mother. Why? How could you possibly dare to leave its bosom? And those animals took to the sky too. And those animals are, well, let's do it this way. When you left the house this morning, how many of those nice, sober, conservative, green dinosaurs who stuck to the land and respected the bosom of the earth did you see? The answer is almost certainly zero, unless you live in a big museum. But this morning when you left the house, how many of the loony dinosaurs who decided to fly did you see? You saw at least a dozen. Why? Because they're birds. And when Chicxulub, the great meteor, struck 65 million years ago and wiped out the dinosaurs, guess what happened to birds? They lived through it. They had more environmental flexibility than their dinosaur conservative progenitors, who had cautioned them with such care and wisdom not to go above the surface of the land. So, and is nature trying to tell us anything with all of this? She sure is. A land-dwelling mammal, a common one, is the mouse. A sky-going mammal, a space program mammal of the same size is the bat. The bat lives 20 times longer than the mouse. In general, animals, that is, in general, sky mammals live 60% longer than land-walking mammals. Is nature trying to tell us anything? She sure as heck is. She is basically trying to say, go up. Go up. And you also see that in mating rituals, because in mating rituals, even on the bottom of the sea, height counts. The altitude you can reach counts, even in the sea. When two lobsters or two crawdaddies go up against each other, they have height contests. And the one who can get its head up the highest wins. And the one who gets its head up the highest is rewarded for its altitude, for its height, for its audacity against nature's most basic law, gravity. It's rewarded with an entire hormonal change. It is flooded with the hormones of victory. Whereas the animals, the crustaceans, who are not able to get their head as high and who lost, go through what the researchers who first discovered this called the equivalent of an entire brain transplant. They are flooded with the hormones of defeat. Those who are flooded by the hormones of defeat skulk around on the sea floor, staying very close to the ground. Whereas those who have been flooded with the hormones of victory raise their heads on high and walk around taller than the crustaceans they have just beaten. The same thing happens on land with lizards. Two lizards go up against each other. They have a height bobbing contest. The one who gets his head up the highest is the one who wins. The one who wins turns a bright green because he's flooded with the hormones of victory and goes up and crawls up to the tallest height of a branch on the highest hill and shows off. And the mammal or the lizard who just lost skulks around as close to the ground as possible and turns a little bit brown, blending into the landscape. It is the progenitor to what you feel when you have just been humiliated and you feel like crawling into a hole and dying. Well, the lizard almost does crawl into a hole and die. It looks for the lowest place possible. So nature has this great emphasis on reaching heights. It has this great emphasis on breaking one of nature's most basic laws, the law of gravity. And in the book, in the case of the sexual cosmos, there's a phrase: nature loves those who oppose her most. Nature loves those who can give her the greatest, who can create the greatest rebellions against her. And the form of rebellion that nature favors the most is height, altitude, getting above the face of the earth, going to the skies. So it is not unnatural for humans to want to go to the skies. We come from a lineage of plants and animals that for 3 billion years has been trying, or actually it's more like 1 billion years, has been trying to get above its raising, as there's a phrase in English. Don't get above your raising. Well, no, I'm sorry. Nature says just the opposite. Do get above your raising. Do go up against the easy surfaces like the sea. Do go up against the easy surfaces like the earth. Be audacious. Climb, fly, soar. So that's the basic, that's the way in which the case of the sexual cosmos makes the case that it is nature's imperative to take to the skies. It is not man's peculiar rapaciousness that makes us want to go to the heavens. It is built into our biology. It has been built in since at least when bacteria first took to the land 1 billion years ago. It has been built into us. So that's the story of nature's 7 great space programs. And I've probably done some of my arithmetic wrong because I see I left the original taking to the land of bacteria out, and that was 1 billion years ago. Oh no, it was 2.75 billion years ago. And that too was nature saying, screw you to nature, with those bacteria who climbed to the land. And again, that first great space program of taking to the land has been so successful that 70% of all the living things on Earth live in the 30% of land mass that is land, that is dry land, non-ocean. So that is the basic point of the book for the space community. Does that make any sense to anybody in the audience? Do we have any comments?
Not yet. No comments so far.
No comments. Okay, so let me tell you a little bit more about this very, very peculiar book. There are 2 great assumptions that are taken for granted in science. One is the law of least effort. Pierre Louis De Maupertuis summarized it in 1750, and he used a phrase that had been cobbled together from things that Aristotle had said, which is nature always takes the shortest path. Nature is a pinch penny. Nature is thrifty. In fact, De Maupertuis said nature is thrifty in all its actions. And the second law that we all take for granted is the second law of thermodynamics, which says that all things are in the process of basically becoming disordered, falling apart, becoming forms of work that are not useful any longer, becoming forms of energy that are no longer work. In reality, the book says these 2 laws are demonstrably wrong. And what is the greatest demonstration of the fact that these 2 laws are wrong? Sex. Now, is sex the shortest distance between 2 points? No, it's the very opposite. It's the longest distance between 2 points that this cosmos has ever been able to conceive. Now, I had to spend 2 years doing my research on sex to write what I wrote in the case of the sexual cosmos. So I cannot possibly repeat it. Wait, hang on a second. We're getting a phone call. Bear with me. I forgot to tell my girlfriend that we're doing this talk this morning. So sex is just the longest thing you can possibly imagine. I mean, there are 8 million atoms alone in that can't be the case. I've got to be misremembering that. There are so many gazillions of atoms in a genome that it's absolutely ridiculous. And the process, those genomes, in other words, the genome itself is one of the longest, most complex things, longest in terms of atom size and linear things. Well, I guess you could say that the giant spurts coming from black holes and from some stars are longer, but these are connected. And it's the biggest chain of atoms that this universe has ever produced. What's more important, the process these chains of atoms go through is beyond ridiculous. They separate the sexes into two, making a male and a female, two different different forms coming from the same string of atoms. They put those pair, the male and the female, through an agony to find each other and manage to mate. Then they go through an even further molecular agony. These two strands come together. Some of their elements switch places, and they have to switch places. I mean, remember, you don't want scrambled eggs to come out of this process. You want a genuine, functioning, living being. That's not easy. And these elements switch places in these two chains without ever getting it wrong. They get it completely right every time. That's almost impossible because this kind of exchange has gone on again gazillions of times since sex first evolved, somewhere between 1 and 2 billion years ago. Then they go through so many crossovers that it is ridiculous. And then they construct a cell. Are you kidding me? They managed to construct an Adriano Ottino or a Howard Bloom. Are you kidding me? That's almost impossible. If we wrote as many books as have already been written today, we could not describe exactly how this happens. It is not the shortest path between 2 points. It is not following Aristotle's law. It is not following Pierre Louis De Maupertuis' law. It is going in exactly the opposite direction. It is inflicting an agony upon males especially, but because males are expendable, females can make do with very, very few males. And females are good. Females use males to test out possibilities. And if a whole lot of males die in the process, that's just fine. It doesn't take that many males to inseminate females or to procreate with females. So the process is agonizing. It has moments of ecstasy followed by years of agony, in the opinion of some writers. And its biological base, what it does molecularly, is beyond belief. I mean, your chromosomes and mine are still functioning in our cells right now, and every minute are basically producing even more of a functioning Adriano Ottino and a functioning Howard Bloom, because we lose about 4 million cells per minute, and they are replaced. Over the course of something like 6 years, we replace every single one of our cells. And yet, there is still an Adriano Ottino and a functioning Howard Bloom. That's defies belief. And is it the shortest path between 2 points? No, it's literally the longest path this cosmos has ever conceived. So the case of the sexual cosmos proposes that instead of the second law of thermodynamics, which we could talk about in a minute, instead of the second law of thermodynamics, this universe is dominated by the first law of flamboyance, which means at every step of its evolution, this cosmos has done something outrageous. In the beginning, in the first 10 to the minus 30 seconds of the universe's existence, that is the first microflick of a microflick of a microflick of the tiny pinprick of the Big Bang, there was nothing but time and space and speed. And time and space and speed, if you'd been around before the universe had flicked into existence, were impossible. They were ridiculous. They were outrageous. They were baroque. They were gaudy. They were show-offs. But within the first 10 to the minus 30 seconds of the universe, that sheet of space, time, and speed spreading at hyperspeed precipitated the way that raindrops precipitate from a rain cloud, and precipitated in quarks, the most outlandish, most unlikely things there ever were. Why? Because this was a universe, despite time, space, and speed, of no thing, nothing, not a single thing. And all of a sudden, there were things. And we are accustomed to dealing with randomness in our calculations, especially our calculations about entropy. Ludwig Boltzmann, around 1875, managed to apply probability theory to prove the second law of thermodynamics, the law of entropy. And that mathematics was the mathematics of probability, which said stochasticity. All kinds of things are likely to happen. Why? Because the universe is stochastic. No, I'm sorry, this universe is not stochastic. In this universe, it's not the most probable thing that happens. Remember, Ludwig Boltzmann claim about the second law of thermodynamics from a probabilistic point of view, which is that some things are very probable in this cosmos, some things are highly improbable. The most probable thing is a chaos. The most probable thing is a state of dissipation. William Thomson, Lord Kelvin, called it the mechanical dissipation of energy in his paper in 1851 that started the whole train of thought that led to the concept of entropy and the second law of thermodynamics. But does the most improbable thing actually happen in this universe ever? Well, if the most improbable thing were always going to happen, and if Ludwig Boltzmann's math were correct, Ludwig Boltzmann's argument was the most improbable, or the most probable things are going to happen, the least probable won't. Well, the most probable is chaos, entropy. But that's not the way the universe has ever worked by making the most probable thing happen. This universe has worked from the very beginning by making the most improbable happen. How do we know that? Those first quarks were, I don't know what you want to call it, manufactured, matured, evolved in gazillions of copies. Gazillions and gazillions of copies all over the universe. And if this were a 6 monkeys and 6 typewriters universe, if this was truly a stochastic universe, a truly random universe, like the universe of Ludwig Boltzmann's math, then there would have been gazillions and gazillions of different forms having nothing to do with each other because they would have popped out at random. That's the most probable thing. It didn't happen that way. When quarks emerged in only 16 different forms. That is not randomness. That is not probability. That is a universe in which the least probable thing happens. Sex is one of those least probable things. Adriano Otino is one of those least probable things. Howard Bloom is one of those least probable things. And you are one of those least probable things. And this general rule that the universe produces highly constrained impossibilities. The universe doesn't focus on creating possibilities. The universe advances by creating radical impossibilities. Let's take when the first 380,000 years after the Big Bang, something very strange happened. Up until then, the universe had been a plasma. It had been a soup of extremely hot particles, which means extremely fast-moving particles. And those particles have been banging into each other at super speeds, bouncing off of each other, ricocheting, and then immediately ricocheting off another particle. But 370,000 years after the Big Bang, things cooled down, which means that things slowed down. And when things slowed down, the strangest, most improbable, almost unimaginable thing happened. There were elementary particles, relatively speaking, the size of the Empire State Building. There were elementary particles, relatively speaking, the size of your fist. The huge elementary particles discovered they had an inanimate longing. The tiny elementary particles discovered they had an inanimate longing. Now, the odds of a particle 1,800 times the size of the smaller particle discovering that its inanimate longing precisely fit the inanimate longing of these tiny little particles the size of your wrist, relatively speaking, is ridiculous. It's absurd. It simply isn't going to happen. There's no way it's going to happen. And yet these big things, protons, discovered their inanimate need just fit each other with absolute perfection and made the first atoms. Well, if this were a truly random stochastic universe, surely with a gazillion new atoms, there would have been a gazillion forms of new atoms. Not at all. There were only 3 forms: hydrogen, helium, and lithium. That was it. This is a rigidly constrained universe, and it does flamboyant things. What did those atoms discover over the next million years or so? That they were being drawn together by a whisper-like force that pulled them toward each other, a socializing force, a force that made social agglomerations. And they agglomerated into clouds of gas and clouds of dust. And those clouds of dust, pulled together by the same whisper of attraction, came together in giant clots, in clots that were millions of light years across. And those clots began to come together. The atoms began to come together in gravity balls. And the gravity balls competed with each other. And over the course of time, the biggest winners in the competition, the rules of a gravity ball sporting event, gravity ball competition are these. We go up against each other. You're one gravity ball, I'm another gravity ball. We see which one of us is bigger, and the bigger one swallows the smaller. You're bigger than me, you swallow me. I become a part of your mass. And that process of agglomeration went on until finally some gravity balls became so huge that they began to destroy the nuclei of atoms at their heart. They stripped the atoms of their electrons, and then they began to crunch the nuclei together. Those gravity balls, those winning gravity balls, are called stars. Now, here's a tip to the non-stochasticity of this universe, to the fact that the universe is anything but random. Those gravity balls all came together in pretty much the same form. They're all, first of all, they're all gravity balls, and that sphere is uniform, that spherical shape, no matter where you look. And they came together as what we call suns or stars. And those stars, wherever you look in the heavens, if you're able to get away from city lights, you will see them sprinkled all through the sky. If you get the best telescope available today, the James Webb Space Telescope, you will see them sprinkled even between the sprinkles. When the Nancy Roman Grace Telescope, if it survives the current bludgeoning of NASA, when that takes to the skies, it will see even more of these things. And they all follow the same pattern. Big blobs, big gravity balls, big spheres in the sky, spheres that become so big that they begin to burn the material at their own hearts. And as for the lesser winners in the competition between the gravity balls, I call these the great gravity tournaments. The lesser winners become planets. And we're now discovering that there are planets all over the place. And there are lesser winners even to the planets. And those gravity balls have become moons. But all of these things are big bowling balls. They are all just big spheres in the sky. Is there a vast profusion of different shapes? Not at all. The same shape repeats itself, and the same processes, like that fiery inferno of the sun, repeat themselves over and over and over again. No stochasticity, no randomness, no Boltzmann's idea that the universe is going to fall apart in an immense soup, that it's going to melt down, although that actually was an idea Boltzmann got from William Thomson, otherwise known as Lord Kelvin, and his partner in crime, who was a grad student initially at the University of Berlin, who actually came up with the two. He didn't call them laws of thermodynamics. He called them theorems, because he was working still on a premise that we forget we once used, that the only real form of mathematics, the most basic form of mathematics, is geometry. And so he called these two things theorems. So the universe, secondly, when it comes to the second law of thermodynamics, the universe has been around for 13.73 billion years as of the latest count that I've been able to find. That's a long time. If the universe were going to experience what William Thomson, otherwise known as Lord Kelvin, predicted, which is the mechanical dissipation of heat, that all things would break down into a random soup, and that was later called entropy and the second law of thermodynamics, it would surely have happened over 13.73 billion years. But let's take a look. Has it really happened? No. We went from nothing to a spreading sheet of space-time and speed, from a spreading sheet of space-time and speed to quarks. Quarks discovered the instant they were born, if you want to say it that way. They discovered they had an inanimate longing, and they had the equivalent of an etiquette book, a book of manners built into them that told them who to glom together with, who to collect together with, and who to separate from. And so they felt the forces of attraction and repulsion. They were repelled by some other quarks, and they were attracted to yet other quarks. And they got together in groups of three because quarks cannot survive on their own. And those groups of three all of a sudden produced a radical new jump up the chain of order, the chain of intricacy, the chain of flamboyance, the chain of complexity. And that vast new leap that could not have possibly been predicted from the mere qualities of just quarks, and you get to put 3 quarks in, what do you get? 3 quarks out. No, the universe doesn't work that way. The universe uses social agglomerations to produce what we technically call, hang on a second, what we technically refer to as emergent properties. Levels of causation, some people have referred to them as, wholes that are bigger than the sum of their parts. Let me get a lozenge here so I don't keep coughing in your face. So the first emergent properties to emerge from threesomes of quarks, if the threesomes were like this, they were protons. If the threesomes were like this, they were neutrons. And a proton and a neutron, well, Aristotle told us, Aristotle laid out a plan for the future of a discipline he called science around 375 BC. And it's all in 2 pages of just one of his books. And he said the way to understand things is by breaking things down to their elements. And then he used a very strange metaphor. He said, these elements follow laws. Laws? You mean really like the things Hammurabi had chiseled on stone that are rules for the behavior of human beings? That's a peculiar analogy or metaphor. And yes, and these were called, if you understand the laws of the tiniest of things, break things down to their tiniest little bits, understand the laws of those little bits, then you understand everything. And Aristotle was profoundly mistaken. We do not come to understand, for example, how an embryo forms by building a $15 billion collider at CERN and breaking elementary particles down to their elementary particles and carrying on the process that Aristotle called for of smashing things to their tiniest bits in order to understand how the larger wholes work. The miracle of this universe is not the tiny bits, it's the holes those tiny bits make when they come together, and the fact that those holes have a whole new kind of reality. They become the next level of hard and fast reality, even though when you were just looking at quarks, you couldn't have imagined proton and neutron. So basically, when those first quarks emerged, they did not lapse into a random soup. They did not become what entropy predicts. There was no chaos. There was order. There was the order that led to protons and neutrons. And just to put the icing on the cake, to show that this universe favors teams that come together into larger wholes that are not explainable simply by the properties of their bits and pieces, their elementary particles, we call them now, using wording from Aristotle. The first neutrons had a social impulse very similar to the social impulse of the quarks. Their impulse was you get together with a proton in the first 10.5 minutes of your existence, or you die. You go through beta decay. So sociality is right there at the beginning of the cosmos, and what comes from social groupings? Larger identities, like the identity of hydrogen, helium, and lithium coming from protons, neutrons, and electrons. The universe then takes another, does it go tumbling down from its production of protons and neutrons? No, it goes tumbling up. That's what the universe does. The universe does not do the most probable thing. It does the most improbable thing. It does not tumble down. It tumbles up. And its next steps included things like cosmic dust, cosmic gas, clouds of cosmic gas, yes, social forms like herds of cosmic dust and of gas, and those things gather together in galaxies. Galaxies were surrounded by planets and moons, and then came molecules, not just simple atoms anymore. Then at the heart of dying stars, a million years into a star's existence, some of the really, really big ones began to die. And in their hearts, atomic nuclei of the only elements that had ever existed, hydrogen, helium, and lithium, were squeezed together with massive force. And the result was 95 new forms of elements. Was the universe going down the stairs like a slinky going down your staircase? It was doing the opposite. It was doing what you would get if you took a video with your camera of a slinky going down your staircase and ran it in reverse, because the universe is a slinky going up the stairs, not down the stairs. So from those 98 new forms of elements, in other words, 98 new forms of nuclei, came molecules. Now, molecular genesis is not recognized as a field in astronomy and astrophysics, but it should be, because the evolution of atoms is one of the most important things, or the evolution of molecules is one of the most important things in the history of this universe. But again, when those first atoms bigger than just hydrogen, helium, and lithium came together, those 95 new forms of atoms, was the universe going downhill the way that Lord Kelvin had predicted, and that Boltzmann would later prove mathematically with probability? No, the universe was climbing uphill once again. And when all these elements began to get together in molecules, was the universe falling apart? No, it was falling together. And it was falling together, in the case of galaxies, planets, and moons, in utterly flamboyant new ways. Now, from those molecules, born in whenever molecular genesis took place, something that hasn't been pinned down, came, guess what? Biomolecules, molecules formed around carbon. And from those, and again, was the universe falling apart? No, the universe was falling together in molecules. And what did those molecules do? Did they fall apart? No, they fell together to make macromolecules. And what did those macromolecules do? Did they fall apart? No, they fell together to make living beings like you and me. So I'm sorry, but the second law of thermodynamics is utter horsepucky, utter bullocks. It just doesn't fit this universe at all. It's had since 1851 to make predictions. That's a long time. And its predictions have been everything will fall apart, and things have not fallen apart since then. On this planet, human societies are falling together. In other words, becoming larger. Human societies are producing technology, which is not falling down, it's falling up. And we are producing something we've been producing for probably about 200,000 years, and we are producing culture. And culture, which works with what one great anthropologist called time binding. In other words, it means that when you're thinking out a problem, it isn't just you thinking out that problem. You are using a language left to you by hundreds of generations of your ancestors. You are using the whole history of technology brought to you by our culture, because the culture is not falling down. Yes, it's had some falls backwards, but on the whole, culture has constantly moved up. Why? Because it is in tune with the universe from which it came, with the universe that gave it birth. And this is not a universe where things fall down. This is a universe where things build up. This is not a universe where things fall apart. It is a universe where things fall together. This is not a universe that prizes the simplicity of Pierre Louis De Maupertuis' law of least effort. It is a universe that prizes the intricacy, the unbelievable intricacy of sexuality. It is a universe that, in the case of beings on a planet, so far we're the only ones we know of, the only living beings we know of. Theoretically, there should be billions and billions of planets with living beings. But all of this is behind the fact that nature impels crustaceans like lobsters and crayfish, lizards, and all the rest of us animals to make displays by showing we can go up to the sky better than our competitors. That's why going toward the sky is built even into the vegetable ambitions of plants. You can see it in trees. You can see it in trees. Lifting oceans to the sky every year, that is just audacious, period. That is persnickety as belief. That is having moxie. That's having chutzpah. That's being willing to challenge nature. That's being willing to rebel against nature. And what has nature shown over 13.73 billion years ago? Nature loves those who oppose her most. And in this universe, it's not the most probable thing that will happen. It's the most improbable thing. So I'll leave you 5 minutes for questions.
Yes, we have some questions. We have some friends connected. Guy Pignolet from La Réunion and Gary Barnard from...
yes, Gary. It's a good friend.
So
I think he's a good friend.
Unfortunately, Sabine had to left because she had another...
Right, she had to pick up her child, I believe.
I will read the questions.
Okay, good.
Okay, let me just to change the view to multi-speaker mode. Okay, that's fine. So the first questions from Guy Pignolet: is Gaia a live being, and is an ecosystem a live being? First question.
We don't know. There's a very good chance because selves emerge, identities emerge when you get these social agglomerations. The way the identity of a sun emerges, the way the idea of the identity of a planet emerges. But there's a chance that an ecosystem has an identity of its own, a higher form, in which the trees and plants and rolling brooks are all a part. But we don't know that. We do know another kind of social agglomeration, an agglomeration of between 35 trillion and 100 trillion cells, depending on which source you're looking at, has an identity that's much higher than its parts, and that's Adriano, me, and you asking the question. And we can tell because at some point, unfortunately, in life, a person like me is going to, I will be laying there in bed, presumably with my relatives all around me, because they know it's my last moments on earth. And in one breath, in one exhaled breath, all of a sudden, the larger whole of me, the larger identity that is Howard Bloom, will be gone. Even though all of my 35 to 100 trillion cells are still functional, are still capable of going on about their business, but the larger entity is so important that in a single breath, I will totally disappear. And unfortunately, that will happen to all of us here. So that larger identity is a very powerful thing.
So yeah, we don't know. You're right. We don't know if Gaia is a living being or not, but for sure is a good analogy because we know that the only way Gaia, if Gaia is a living being, the only way to reproduce itself is to have a species like humans.
Yes.
We have the mean to make her give birth to a solar civilization. So that's a good analogy, I think.
And look what nature inflicts upon her creatures. To find a female, some sperm travel the equivalent of the distance from where I'm sitting in New York right now to Venezuela. They travel 12,500 miles, the equivalent of 12,500 miles, just to find a female, just to find a mate and a date. So travel horizontally, we did that because that was the best we could do.
Definitely, travel is very important. Very
right.
important. So, okay, let's go ahead. We have other questions, a few other questions. Another friend that we don't know yet, but maybe this friend could join SRI as well. Wufon is called, Wufon, Howard. Love the way you frame this natural history as you think about the history of what has happened in this laboratory on Earth. Do you see similar experiments happening on worlds throughout?
As I said, there's a principle that I mapped out in one of my physics papers, and it's called the Xerox effect. And it's pretty much the same thing, happens pretty much everywhere in the cosmos at pretty much the same time. The evolution of atoms, the evolution of galaxies, the evolution of stars, the evolution of planets, they're all pretty much the same. And they all work on the same principles. It's blobs and spheres all the way, with a swirl every once in a while. So it is excruciatingly probable, 99.5% probable, that whatever process has produced us, whatever process produced life, has happened on other planets too.
Yeah.
And yet we see zero evidence. The little trickles that we are told might be evidence of life, like the dimethyl sulfur in the clouds of one exoplanet, those are those are weak evidence, very, very, very weak evidence. And so far as we know, we humans have only happened here.
Yeah, if we have to think, sorry with Gary, because, and the other questions, because I am okay, excited to go ahead and discuss a little bit. However, if we think that the life should be similar to the Earth biome, then we should better think in terms of solar systems, because in this solar system, only the third planet has the condition to generate life as we know it.
Right.
But if life forms could be different, maybe even in other more distant from the sun, planets more distant from the sun, there could be an environment generating some kind of life. We don't know that. And so I agree that the forest live because there are hundreds and thousands of plants together making a system, a biosystem, a network.
And a rainforest makes its own weather.
One only plant,
right,
is very, very more in danger to die because it's alone. So
right.
I don't know in which dimensions we have to think when we think about life sustaining environments.
Right. Unfortunately, people who think about the planet and use the word often don't understand nature, because they think that the planet is this giant thing that was perfected before man arrived somehow, and that we are the great disgrace to nature, that we are nature's greatest enemy. But look, once upon a time, nature produced bacteria. And those bacteria, she created bacteria that had a bizarre technology. The technology involved kidnapping what's only a wiggle of some kind. It's not even a thing. It's a wiggle. And dragging that wiggle into the life process by harnessing it to produce carbohydrates and sugars. That bizarre technology was photosynthesis. And photosynthetic plants, once they got the hang of this, it spread widely all over the world. And like all of us creatures, including you and me, these bacteria farted out what they couldn't digest, and especially what was poisonous to them. And what's a little bacterial fart in a massive, massive atmosphere? Nothing. But over the course,
You remember,
over the course of
industrialization of life.
Right. So those farts over the course of 1 billion years built up in the atmosphere. And because it was a poison, that's why the bacteria had to get rid of it. It became so thick in the atmosphere that nearly every creature on Earth died off. And then some tiny little archaea bacteria had found a way to use it, because life finds a way to use just about everything.
Yeah.
And every new life form means an entirely new recipe for what to turn into food. The few remaining big bacteria took on the little bacteria as borders. They made a deal. In essence, they said, look, I will give you a paradise. I will give you every kind of food that you like, everything in your environment that you like, in exchange for only one thing. You take this poison that's poisoning the atmosphere, and you turn it into an energy source for me.
Oxygen.
Yes, right. Yes, oxygen was the poison. And nature did that, Adriano. That was not done by human technology. Nature did that.
Yeah.
So nature recovers from her errors, and except it's not going to take nature hundreds of thousands or millions of years to recover from us, because we are our own recovery device. We are self-critical. That's a correction mechanism. We have seen the difficulties produced by human-made things ever since at least 1951, when Silent Spring, Rachel Carson, was written. And a movement has grown around Rachel Carson.
Bob Zabrin wrote about that.
Right.
Merchant of Despair.
Right.
Yeah.
So that movement has grown until it's poisoning our dreams and it's poisoning our sense of possibilities. Any good thing in excess is a poison, and some of the environmental extremism is a poison.
Yeah. So let's try to go ahead. Maybe another question by Wufon, the Cosmos. And can you imagine? No, it was a continuation of the previous one. And can you imagine that Earth's inhabitants will be the first to leave the planetary cocoon?
Will be the first to live what? The cocoon of Earth?
Can you imagine that Earth's inhabitants will be the first to leave the planetary cocoon?
Yes. We're doing it. We've been doing it since roughly 1969. No, Yuri Gagarin was probably a year before that. So, we've been doing it for a long time. And the Starship, which is in development, SpaceX's 100-passenger vehicle, will carry large numbers of humans to space. And Elon's able to make his plan happen, and I'm sure he is, carrying large numbers of humans to Mars to set up a self-sustaining economy there. So yes, humans are in the process of leaving the cocoon.
Let's go to Gary Barnard. I don't know if I have to read each question or all together. Let me see. The notion of an effective anti-entropy generator does not necessarily violate the second law of thermodynamics.
Oh my God, it's Ilya Prigogine.
Because
and his idea that what makes form is...
Because life is an instance of local maxima aggregation of energy.
Oh my God. So I love Gary, and I really do. But the fact is, Ilya Prigogine came up with the same argument. He won a Nobel Prize, that in order to create form, you have to create even more entropy. And it's ridiculous. It's absolutely ridiculous. You do not, I was just reading this argument in the book that I'm reading right now, Intraterrestrials, which is about bacteria in the deep ocean. And the author claims, paraphrasing Ilya Prigogine, that it is entropy, that is the spillage of chaos, that makes form. I'm sorry, form is intricate. Form, we don't know the rules that make form. That's a very important thing to understand, understanding how morphology happens, why morphology happens, why form is produced, even forms of crystals, non-living things. That we understand far better. than living beings and their form. Form is a mystery. And if we don't get our head out of our tail, and if we don't stop looking at everything as being explained by chaos, and instead look at the exquisiteness, the intricacy, the astonishments, the first law of flamboyance effects, if we keep looking backward and imagine we're seeing the trip ahead, we're going to just waste, and we are wasting currently on entropy. We are wasting hundreds of millions of hours of effort by some of the most intelligent people on the planet pursuing these bizarre arguments about entropy. Nobody has shown up yet to say that the emperor has no clothes.
Okay, let's go ahead. Life can not only adapt to an environment, but it can also learn to change the environment. Your ongoing quest to rattle the intellectual cages we have become accustomed to continues with effect. Bravo.
I couldn't understand most of that. Life changes its environment. I got that.
Life can not only adapt to an environment, but it can also learn to change the environment.
Yeah, and that happens all over the place. Birds make nests, these pieces of woven architecture. Termites build mounds that are something like 153 miles high compared to the size of their body. And they're incredible pieces of architecture, and yet no one termite has any idea that they're doing it any more than your liver cells know that Adriano Otino is the result of their efforts. Ants dig colonies that are very intricate under the ground. All kinds of creatures change their environment. So if you were to say nature abhors those who change their environment in order to say nature abhors humans, I'm sorry, nature doesn't abhor those who change their environments. Beavers make dams. All kinds of creatures change their environment. So it is nature that gets us to change our environment. Nature uses us. Nature has a toolkit of possibilities. And the toolkit of possibilities was only so big in the days of stars, moons, and planets. But since animals came along, or even since plants came along, that toolkit of possibilities has grown enormously. And the biggest growth in the smallest amount of time in the number of tools in nature's toolkit of possibilities has come since 40,000 years ago when humans began a cultural explosion. We are the greatest contributors to nature's toolkit of possibilities.
I think you remember Octavia Butler. She's a science fiction writer.
Yes, her name has come up this week.
The Parable of the Sewer or something like that.
Right.
Infamous work. And she write a simple sentence saying that God is change.
Yes.
So
yes, absolutely.
The only rule in nature is change.
Right.
Nothing is freezed forever.
Well, the other rule is the first law of flamboyance, because the change has a direction. And that direction is toward greater flamboyance, up. Greater intricacy, and up. Yes, exactly.
I agree very much. Okay, going ahead. Okay, there was some last sentences by Gary. He says, life is a herd of Schrödinger cats. Quite interesting. And okay, Buffon says that Buffon is Bill Gowan. I apparently joined with some old YouTube account name. Okay, good. And I am a member. Okay, he's a member of SRI. That's very interesting. I didn't recognize him. M Ultra is another friend writing something. Is it basically about fusion and fission? Okay, I don't understand to what this
Well,
question
let me
is.
address fission and fusion for a second. Fission and fusion patterns are basic to the cosmos. Fission is spreading out, stretching, and exploring things. And fission is coming back together and comparing notes, basically. And so the phrase fission fusion strategy is used in evolutionary biology to describe the search patterns of, was originally used to describe the search patterns of chimpanzees. But you can find those two. There's a Bloomism. Opposites are joined at the hip. And you can find fission and fusion joined as parts of a common search pattern at many, many, many levels of the universe, and especially with sex, because nature uses males to go out and search. She uses males to go out on great adventures, like the sperm that traveled the equivalent of the distance from New York to Venezuela. And she uses females for security, to sit there and in a safe place that's already been tested for its safeness and entertain these visiting males who have come from their great adventures. And nature uses males to make sure that before a female commits to a male, that male has been thoroughly tested. I mean, we are all over the age of, many of us over the age of 50, and it gets hard for us to remember just how hard it was for us to find a mate, and just how hard it was to prove that we were worthy of having a mate. So fission, fusion, or joined, even in the male-female duet, because the male represents fusion or fission, sending out feelers and exploring, and the female represents fusion, coming together and consolidating what you've learned. Okay. And my voice is beginning to give out, so I should probably
take some water.
Yes, that's a good idea, and I've got my lozenge in my mouth.
I think we are near the end. However, Dan, always am ultra say the Earth is a living organism that can take care of itself. Aliens may be energy farming people.
So Earth is a living organism. So we know that James Lovelock and Lynn Margulis, who was kind enough to act as a mentor on one of my books, that they managed to demonstrate that the universe, the planet and life, the life upon it, are self-regulating. That the combination of the planet, hang on, more water, and the life on it keep the temperature on Earth within a limit that allows life to survive. Now, that limit involves ice ages and it involves global warming.
Yeah.
But it is kept within a certain boundary.
Yeah.
Lewis Thomas wrote a book called The Lives of a Cell, comparing the Earth to a cell. So, yes, the Earth can be regarded as a living system.
Yeah, it comes to my mind the work of an Italian scientist that is studying the vegetal life.
Right.
And he says that the 97% of life on Earth is vegetal.
Interesting.
And only the 3% is animal, and only the 0.3% is
human.
Our species.
Right.
And he makes several interesting considerations about vegetal life. He says that vegetal life has some kind of intelligence because they can cooperate together.
Right.
they can also organize themselves. He showed an experiment that's quite strange. They put in a glass bowl
Right.
some ground and seeded
Right.
some plants. Then put a cover on the bowl with an heavy pound on it,
Right.
and the plants organized themselves to all together to push away the cover in order to reach the light.
Amazing.
That's incredible. They don't have a brain, of course,
But they work together when they're threatened.
they know how to work together to organize.
When a horse when a horse in Kentucky begins to eat one cherry tree in an orchard, the cherry trees send out a signal of distress. And it's not just the one cherry tree that sends out this signal. The entire grove of cherry trees will begin to send out chemicals that can poison the horse.
Yeah.
Or send it away. So yes, plants have their own form of cognition, you could say.
It made me think that there are also things that we humans can try to learn.
Right.
Not only from other animals, but from plants, the collaboration, for instance.
Oh, absolutely. Plants are a miracle. But the universe is replete with what I call in my books material miracles.
And not only the ferocity of wild animals that now is so much in fashion, no? Because
right.
people love the ferocious animals because they are innocent, no? They kill.
But there's another aspect to the ferocious animals, and there's another aspect to 97% of life being vegetable, 3% being animal, and 0.5% being human, and that is nature glories in hierarchies. A sun is at the center of, or at the top of a hierarchy. Planets are beneath them. Moons are beneath those. An electron in motion around a proton goes wherever the proton wants because the proton's got 1,800 times as much mass. So those are hierarchies. And nature, unfortunately, glories in having top animals. Animals at the top of the hierarchy. The lion is generally considered to be at the top of the hierarchy in Africa, for example. And humans are hierarchical, as you can see in every social grouping around, with the exception of small communes that try to be egalitarian and winkle out of existence in 50 years or less. So you could say in hierarchical terms, something I'm sure the Bible tries to imply, which is that nature has made all of this to feed humans, to put humans at the top of the hierarchy, to make humans the keystone species, as ecologists put it.
Yeah. So, okay, something more. The collections over the night do not. It says, Gary says, the collection of statements are all connected. Howard and I do not disagree.
That's wonderful.
Yeah. And M Ultra, last sentence, do you believe that yin-yang Kabbalah understanding of the universe can ever lead to a good for all nature, or is it purely a sacrificial system?
It is a highly sacrificial system.
You want me to read it again?
Well,
Because
let me just talk about sacrificial.
I have read it, but I haven't understand. So
well, the sacrificial aspect is definitely there. Why in the world did nature invent death? Now, admittedly, even stars die. They die in supernovas. As I said long ago in this conversation, the really big ones die after only 1 million years. The other ones have longer lifetimes, but they too will die. But when it comes to living beings, the number of individual beings who lived on the face of this earth is gazillions. Absolutely gazillions. Why? Because nature is addicted to death. Every single one of them, us attending this event, is unfortunately going to die. And that means nature is relying on an incredible reproductive power, a power for mass production, and that goes manic mass production is what I call it. It's just nature is relying on this astonishing ability to produce gazillions of individual beings, and that's why she takes so casually killing them off. But why does she kill us off? We don't know that, and it's nature who does that. That is not a flaw of humans. That is not a result of smokestacks and tailpipes. It's not a result of modern industrialism. This is the way it has gone for 3.75 to 4 billion years. Why? That's a question I ask in the book. I try to answer it in the book, but in reality, I'm still looking for the answer.
Quite interesting. I think everybody will be interested to read it, of course. It can be found on Amazon, correct?
Yes.
Excellent. So if you give me, no, I think it is in our description on the YouTube. No, can you please put here in the chat?
Yes, hang on, let me go get it.
So I put it in the chat of YouTube.
Hang on, let me find it. I had it here somewhere in my notes. No, no, that's our notes for, damn it, did I just get rid of my main note? All right, let's go to my browser where I should have it up.
Put it in the chat.
My browser. I'll have to send it to you after the session.
Oh, you cannot put it in the chat here?
I can't find it. I can't get my browser to work.
In the bottom.
My browser has it.
In the bottom.
Let me shrink us. And okay, I'm looking for my, no, okay. I'm terrible at this, Adriano.
Okay, never mind.
Okay, I'll send it to you afterwards and hopefully you can send it out to the group.
That's fine.
And the reason you didn't have it was the book just came out after we last communicated. It just came out, I think, about 10 days ago or something like that.
Okay, great. So, there is a last sentence by Ultra. I believe connecting to a creator force rather than relying on a created force is the key to escaping death. Okay, I think this is
yes, it's a religious argument.
At least, yeah, theologist.
Yeah, and I am a man of faith. I am an atheist, and I have total faith in my atheism. So that approach, the argument that Ultra alluded to, is one I just don't believe in. And I think even if we believe in God, it is our job to do his work or her work. It is our job to find out as much as we possibly can about why all of these mysteries exist.
Yeah. Myself, I am an agnostic because I think that there are the same number of arguments in support of the existence of a God and the same number of arguments in support of not existing.
Right.
Nobody can have a scientific proof.
Right.
One or the other thing. Therefore, I think I am agnostic because I'm open. Who knows?
Right.
There is an argument that is similar to one that you used in your presentation today. Yeah, a person, a believer, told me, think about throwing up thousands of alphabet letters.
Right.
And these letters going to the floor compose the Divina Commedia. This is the possibility that the intelligent life was grown alone without without a project, let me say.
Right.
This argument was used to demonstrate the probability, I say the probability of existence, not the existence, of course. But I think it's a very strong argument because as you say, the improbable things happen in the
This
universe.
universe specializes
Yes.
in making impossible things happen.
And this is not strange, it's the rule.
Right.
Nature is working like that. This is a very, very, very important achievement of your elaboration and in your book, I think.
Well, I hope everybody buys the book, and I will provide the URL and reads it and lets me know what you think. Fortunately, the initial comments are extraordinary, absolutely
And
extraordinary.
we could also maybe try to find an editorial house to translate it in Italian.
Well, that would be absolutely fabulous.
Yeah, because I think in two countries it will be important, Italy and Germany, because they are the country of philosophy,
Right.
Therefore, yeah, I think it would be interesting to talk to our Professor Marie-Louise Heuser. She's a philosophy teacher in a professor in Germany.
Right.
The university. We can try. Okay.
That would be great. Wonderful.
So I think, well, we are exactly in time, 1 hour and a half, so we can close this very interesting webinar. Thank you very much, Howard, for being with us.
And thank you, Adriano, for inviting me, and thank you to everybody who's watching this right now. It's a pleasure talking to you.
Of course, it will remain on YouTube, so people can watch.
Terrific. Send me the URL, and I will social network it.
Okay.
Have a great night.
Take care. Ad astra.